Good afternoon and welcome to our webinar, Desktop Virtualization Steps for Success. My name is Kevin Cook and I'm a Market Development Manager with Terakai Corporation. Today we will be presenting part 2 in a 3-part series focused on virtual desktop infrastructure, the next generation desktop strategy. I'm very pleased to introduce Matt Boyajian. Matt is an industry leader and virtualization expert with over 13 years experience in designing, architecting, and optimizing desktop implementations. Today he'll present on how the move to virtualized desktop infrastructure requires us as IT professionals to plan a bit differently. Specifically, in this part 2 of the series, we will focus on deploying desktop virtualization architecture. And so without further delay, please welcome Matt.
Good afternoon, ladies and gentlemen. My name is Matt Boyajian. I'm a solutions architect, and today we're going to be going over the steps successful of VDI. Today we're going to be covering steps 5 through 7. Now, a couple of insights that we're going to talk about first. Number one, if you have not seen the portion of successful steps to VDI part 1, I strongly recommend that you either go to Terakai's website or contact Terakai and ask for a copy of the presentation, because we covered a tremendous amount of information within the first session. The second session, we're going to be getting really into the nitty-gritty here. We're going to be talking about specific things that we can do to optimize all the modern operating systems that most companies are looking to virtualize today. We're going to be talking about what we can do in terms of under the covers of the operating system, what we can do for our applications, what can we do for our virus scan implementations, and we have a lot of individual things that we're going to be covering to tell you as to why you should have them on or off and what you can do in regards to these things to make them more efficient in your environment. So, let's get started. Also, one other thing I should mention, I have a tendency of speaking a little bit quickly. I'm going to try to tone it down a little bit for the purposes of this presentation because we are in audio-only mode. But if you have any questions whatsoever, if you'd like anything repeated, or if you just have a Q&A that you don't think that we've covered, please feel free to let Terakai know, and I will be addressing those questions at the end of the presentation, regardless of how many of you might ask them. So, let's talk about step 5. That we've already talked about steps 1 through 4 in the first presentation, but step 5 is going to be virtual image optimization and general best practices. Excuse me one moment. I'm going to get rid of one little nag screen. Now, there are 4 main areas we're going to need to minimize utilization across the image sets in order to be the most effective within our image. Now, the first question I usually get in regards to this type of methodology is why? Why do I need to do this? I should be able to just take my physical image that I have right now, convert it from P to V, and then just have that be hosted through my systems. And that's a VDI implementation. I'm trying to decrease the amount of images that I have across my infrastructure. I am not looking to increase the amount of images. So why am I going about doing this? The first thing that we have to keep in mind is that virtualization in and of itself is a very, very different animal than physical desktop infrastructure. Now, within your physical desktop infrastructure, your requirements for each client and the amount of resources we can dedicate to each client are very, very cast in stone. Typically, we have more CPU than we need. Modern systems have anywhere between 4 and 6 cores, operating anywhere between 2 and 3 gigahertz, which is a pretty decent amount of CPU by and large, and most folks aren't going to be using the majority of that. Memory also is kind of over-allocated. Most new systems are coming with 4, sometimes 5, 6, 7, 8 gigs of RAM, and the utilization across that is limited. Hard disk utilization, however, is very, very different. Now, a standard desktop system with a 7200 RPM high cache rotating hard drive through a SATA 3 interface has the ability to serve out about 100 IOPS. Some a little bit more, some a little bit less. Laptop drives can actually serve out about 80. The new high-speed ones can do more than that. SSDs change the game completely. SSDs, while they're very expensive, they have not reached mainstream yet. They can, in some cases, serve out to 5,000 IOPS. Now, your data center, your SAN, your NAS, your DFS, the thing that you're actually allocating towards VDI can serve out a lot more IOPS than just 100. If designed appropriately, many thousands of IOPS is not outside of the realm of possibility. Now, that being said, your current physical image is designed around the physical parameters that you have. You have so much CPU, so much memory, more than you need, fewer IOPS than you need, but at the same point, you don't care if you use all of them. If you're using 100 IOPS, that's fine. It's your resources. That is what it is. And as far as we're concerned, if an impact of a user's behavior only impacts that one system, And the reality is we really don't care. That user is essentially their own worst enemy. They're contributing to their slowdown in speed. Now, within VDI, the landscape changes dramatically. We are no longer unlimited, so to speak, in terms of CPU and memory. And granted, we have a very high horsepower, high IOP capable storage infrastructure, but the problem is that if every single user were to consume 100 IOPS, even for a small period of time, VDI would be brought to its knees. So the other thing that we have to consider is that we're trying to minimize costs as much as possible. The ultimate greenfields landscape is to get to a VDI infrastructure that costs as much or less than a physical desktop. Laptops are a little easier because they are rather expensive, especially in terms of support, but that's where we really, really want to be. We want to be able to give the user an experience that's as good or better than what they currently have within their physical desktop, and we want to be able to do it at the lowest possible cost. Now, from steps 1 through 4, we covered non-persistent link clones and how that's considered the holy grail of VDI, but the simple fact of the matter is that resources are expensive when it comes to VDI. Therefore, the more we reduce these specific resources, the less VDI is going to cost, and more importantly, the more that we reduce these resources, particularly idle resources, the more clients that we're going to be able to fit within our environments, within our hypervisor, within our servers, within our storage infrastructure, and within our network infrastructure. So, with that, with the introductions out of the way, let's talk about the 4 main areas where we need to minimize utilization across the image sets. First, and by far one of the most important, is IOPS utilization. For those of you who don't know, IOPS stands for input-output instructions per second. Now, anybody who's been focusing on the desktop side for a long time says, well, why do I really need to care about IOPS? Really, megabytes per second or kilobytes per second is really what I've been measuring for benchmarking hard drives for the last 10 years. Why does IOPS suddenly matter? Because an IOP is the amount of traffic akin to a network frame. So, like when you send a network packet or a piece of information out of your network device, that single packet is recognized and handled and treated by your switch accordingly. And now, technically, it really doesn't matter how large that packet is. The packet could be 1 kilobyte, it could be 1,000 kilobytes. It doesn't really matter. That one packet still consumes a packet's worth of information. Now, an IOP is very similar to a network packet in the fact that that input-output operation is what the hard drives or group of hard drives can natively handle within one transaction. That being the most important thing is a transaction, because the amount of data that we can write during a transaction is variable. But the amount of IOPS that a hard drive can actually respond to, if the size of the packet is static, is not. We're always going to be limited by the amount of IOPS that we can always serve out, be it on a storage device, be it on a hard drive, be it on an NFS, DFS, SAN, whatever we have, it's always going to be the limiting factor. The amount of megabytes per second or kilobytes per second you can transfer is going to be variable. So that's why IOPS is king. Now, specifically, what we want to do is we want to minimize idle IOPS as much as possible within the image. If an image is not being utilized by a user, but is still generating IOPS traffic, then that traffic is taking away from what other users can request of that storage system. Now, if you're using non-persistent link clones, you might be saying, well, who really cares? I've got 1,000 users, I've got a pool of 500, 400 of those are being utilized, but 100 of those are just sitting there idle. What difference does it make if they're actually generating traffic? The answer is a lot. So let's just throw out some numbers real quick. Let's say, for example, that if you're using a Windows XP image and your standard P2V image generates around 5 IOPS of idle traffic, which is fairly normal. Now, if you optimize that image, really, really go whole hog after it, and you just optimize everything you got, you can get that to around 1.8, 1.7 IOPS. So you've basically freed up about 3 IOPS per machine. Now, considering the fact that you've got 100 machines that are sitting there and spare idle with your pools, that's 300 IOPS. That's a decent amount of traffic. That's akin to 2 15,000 RPM raw spinning disks, taking nothing into equation in regards to RAID structure. So being that these kinds of disks are expensive, the more we can decrease that, the better off we are, the more machines can run, and the faster we make our infrastructure. Again, because the more spare IOPS we have, the faster our storage is going to be. Now, the last thing that I want to point out about storage, in regards to infrastructure speed, your storage subsystem is the slowest subsystem of any computing component. meaning that you can perform so many cycles worth of memory access and CPU access and network access. The one that is by far the slowest is IOPS. It is the weakest link in the chain. Therefore, the faster you make your storage, the more responsive you make your storage, and the more IOPS you pull off of the load of that storage, the faster VDI is going to appear to the user. Now, next up we have to talk about CPU utilization. Now, CPU utilization is just as important as IOPS. Idle CPU utilization, just like IOPS traffic, will detract from the users who are trying to use the host to perform actual work. By minimizing the amount of currently running applications present in the image, we can reduce idle CPU traffic. Now, for a lot of folks, that's not going to be an option. There are certain agents that you have to have within VDI. But if you just do a P2V, you're going to find a lot of things that you don't need to have in the image. All the local sound driver agents that may be present within your system. Defragmentation programs that aren't really necessary anymore. Things that you just do not need within the image have to be scrutinized. Now, why? Because we talked about before how desktops have a lot of CPU power. And in terms of servers and hypervisors, the same is true there. We have lots and lots of CPU power. Why do we care about minimizing that traffic? Because the CPU in a VDI environment is not just performing CPU duty for your users. It's actually doing quite a few other things. So the first it's doing is it's giving out the CPU for each user. The second thing that it's doing is it's monitoring its own internal operating system and hypervisor. So it's already performing double duty. It's monitoring multiple operating systems and squeezing all that in and time slicing it around to make sure it runs right. But that's not the only thing it's doing. The CPU is also handling all the graphics traffic for all your clients, and in a lot of other areas it's handling all the little backup upkeep work that needs to be performed among the other areas of VDI. Some network functions are handled by the CPU. Virtual switch functions, provisioning functions, I/O functions. Lots of things are being done by that CPU. So the more load that we can pull off it, the more resources we can grant to users who actually need them. And with the CPU doing so much work, it becomes just as important as IOPS traffic in making sure that the user experiences VDI as good or better than their desktop or laptop. So with that, we're going to talk about the next two portions, which is memory utilization and network utilization. Actually, we're going in order of importance, but keep in mind all four of these areas are always extraordinarily important. You cannot ignore any single component if you want your VDI environment to be a success. So the next thing we're going to talk about is memory utilization. Now, idle memory utilization is a particularly troublesome issue to contend with, as memory compares very similarly to IOPS traffic as cost-prohibitive resource. Memory is not cheap. CPU, in effect, is cheaper than memory in many cases. Now, by reducing the amount of idle memory within a system, we can allocate more systems per host when they are not CPU bound. Typically, most VDI sessions are not CPU bound, so minimizing image memory footprints becomes imperative. There's a lot of other things that we have to talk about here. Now, memory utilization within a hypervisor is a very, very tricky thing. The logic being is that, let's say, for example, you have a desktop with 4 gigs of RAM, and you're using 3 of those 4 gigs of RAM. And when you move to VDI, you say, well, excuse me one moment. When you move to VDI, you say, well, you know, that's fine. That's all well and good. I'm going to give this client, 4 gigs of RAM and everything should be fine. The problem is that you have reservations within the system. So in terms of the hypervisor, the way it functions is that you're trying to over-allocate clients for RAM, meaning that if I have 128 gigs of RAM within a server and my clients are allocated 136 or 140 gigs, that's fine. Everybody's going to continue to function because not everybody's using all the RAM that they have. So in order to facilitate that need for over-allocation, the operating system, through the included tools of the hypervisor, then interfacing with the server, is going to do something very, very different than your standard OS will do. Typically, unless you tell it otherwise, a hypervisor will start paging to disk beyond 50% memory utilization, which a standard OS will not do. So as soon as you get to 2 gigs out of that 4 gigs on your system, you're immediately going to start paging RAM to disk, which is going to cause huge jumps in your IOPS traffic. Now, because IOPS is the slowest subsystem of your system, you've just decreased the amount of experience that you can dedicate to that user. You've made their VDI experience poor. That's bad. So what we need to do is decrease that memory utilization as low as possible. And if we have users that are creeping up past the 50% mark, we need to increase reservations, or the amount of memory that the system is going to have allocated before it starts paging to disk. That's a very delicate balance. It's also something that's a little bit difficult to achieve within certain user groups, which is why a monitoring tool is a must within any VDI solution. If we have a monitoring tool and we can actually evaluate who's paging to disk, who's not, who has enough memory, who doesn't, then we can allocate how the machine should be configured per user. Because ideally what we want to do is identify user behavior and make sure that the amount of resources they have is enough. Because you don't want to just give a cookie cutter image to everybody. You don't want to give 6 gigs to everybody when they only need 2. You don't want to give 1 gig to somebody when they need 3, because again, this will be very, very inefficient, and you're going to have issues creep up all over the place, mainly relating towards paging to disk, idle IOP utilization, as well as under or over allocation of memory. So be very, very careful with this. The trick to remember is the more that we decrease the memory utilization of our clients, the easier this gets to do. Because if all of a sudden my memory requirements are 50% what they were before, it becomes much simpler to manage my images, manage my users, and monitor their behavior. All right, the fourth area we're going to talk about is network utilization. Now, idle system network utilization is the last major resource that VDI systems contend with. Although the internal vSwitch can help alleviate group traffic concerns, and recent advances in network switch design have improved network handling immensely, specifically 10 gig. 10 gig is great. You know, it's almost like infinite traffic. Network throughput should never be overlooked. Any increased latency within your network, especially the transport, can be directly impact your users what they will perceive as slow. Why is that? Because when we're talking about VDI as a large-scale instance, we're no longer relegated to a single server. We're no longer doing things within one box, meaning that a lot of times what happens is that disk traffic gets translated into network traffic, and video traffic gets translated into network traffic, and application traffic gets translated into network traffic, meaning that if I have a slow network resource because it's over-allocated or under-allocated by what terms of a user is actually doing with it, then the applications the users run will be perceived as slow. And that's just as bad as not having anything at all. Because if a user considers something to be slow, they're not going to use it. And if it's not being used, then it's a tool that's out of your toolbox. It's a tool you cannot use. So what we want to do is decrease the amount of idle network utilization, the same way that we're going to do memory, CPU, and IOPS. And this is going to be true for every single VDI system that you have, every single image that you have as well. Now again, this is not something you're physically concerned about within your existing desktops or laptops because they run the way they run. So you're going to have to go through every single service, every single process, and every single application that you have on your images and the ones that are running in your VDI environment with a fine-tooth comb. Now, that seems like an almost insurmountable exercise. That seems like a huge amount of work. So what we're going to do is we're going to help you out with best practices to get you to the 80% level. So just by following what we're talking about here today, if you employ these best practices, you're going to be 80% of the way there towards optimizing your image for VDI. All right, so let's get right into the nitty-gritty. Let's talk about specific operating systems. Now, we're not just going to give you a cookie-cutter stamp, just do all this, because the reality is that's not good enough. We need to understand why we're doing all these things. And each operating system handles these things a little bit differently, so it's a good idea to understand the difference between XP and Vista and 7 as to why we're doing these things, because they will have different impacts depending on your platform. So, XP is one of the more popular VDI operating systems, mainly due to its widespread use and low overhead. It's a very, very cheap OS to run. That being said, there's still a lot of optimizations that can be made to improve its performance. Now, depending on your environment, some of these things might not be feasible. Some of these things are going to be requirements by your environment, but they should still be examined. So let's take a look at all these right now. Installing VMware tools, if you're on an ESX or VMware hypervisor environment, this is a no-brainer. This is something you should always be doing. Now, if you're in a Citrix environment or a Hyper-V, again, whatever tools they have available, utilize them. You want native drivers. You want native control. Otherwise, it's just going to slow the system down. Next up, disable as many system processes as possible. Now, you might be asking, why is there not a list of all the system processes within XP? And the logic being is that there's too many to cover within a couple slides or a 1-hour presentation. Now, there's lots and lots of guides on the internet that you can look up for free that are going to teach you how to disable all these system processes. The thing is to remember, it's different from every environment. Some environments use different processes than others. There are a lot of things that you can obviously turn off because you're not going to be using them. Things like Windows Wireless Zero Service Config. You're never going to run wireless within VDI, so it shouldn't be present within the system. The best idea is to look at some of the best practices, some of the best guides, and keeping in mind that we're doing this for a POC experiment. Within a POC, you have the ability to get a little bit more aggressive than you would within productions. Try as many things out as you can, see what works, see what doesn't work, see what your users find better or worse in regards to their systems. Next up, we're going to talk about some of the easy ones, COM ports. Now, COM ports seem like a fairly benign thing. If I'm not using a COM port, why does it matter? Because comms actually generate something called an interrupt. Consider a CPU a lot like a clock. And every single time that hour hand goes around, every time it comes back up to 12 o'clock, the CPU is going to check something called an interrupt table. Now, the interrupt table basically says, all right, I want to halt the CPU and run this little bit of code. Now, COM ports, if they're not being used, should not be generating an interrupt. However, the CPU still has to check it. And if you've got 1,000 users or 500 users or 100 users on a system, and every single time that CPU cycles, you got to check that interrupt, that adds up to a whole lot of work that you don't need to be doing because you're not using a COM port anyway. So by default, just turn it off. It's one of those little things that's going to start to add up over time. Same thing with LPT ports. They use an interrupt. Even though we have DMA, direct memory access, these things are still going to slow a system down in terms of large-scale implementation. So turn it off by all means. Next up, disable CD-ROM drives. Now, this is sometimes a point of contention for users. They say, well, why would I want to disable a CD-ROM drive? What if I have a client that needs to install an ISO or anything else? The short answer to remember is that the CD-ROM drive requires a driver, requires a startup sequence, requires an interrupt, requires all these other things that we have to use. It's going to slow the system down in a very, very tiny way, but added up over time, it's going to cause a little bit more resource consumption than we like. The other thing to remember is, why are your clients using CD-ROM drives? If they're installing software into a VDI environment, then that's going to be a problem because you need to monitor everything that they're doing. So ideally, what you should be doing is if your client has what we like to refer to as shrink wrap or out-of-the-box software, they should be bringing this down to your integration lab or your packaging team or somebody so you can validate it against the VDI image first to make sure that it's not going to bring the system to its knees. So by turning off the CD-ROM drives and eliminating that portal into the system, you're going to lock down that image a little bit more, make things nice and stable, and pull those resources out of the system. Next up, disable the superfetch service. Now, why would we do this? Because superfetch is a prefetch environment designed to speed up I/O. It should make things faster, right? Well, it does in a physical environment. The problem is in a virtual environment, it's just more overhead. So turn it off, and it's going to help things out a little bit. Next up, disable NTFS last access timestamp. Now, your security group might have a problem with this. If they do, you can leave it on and everything's fine. But what the last access timestamp does is it prevents the time a file was last accessed from being written back to the file. Now, why would we turn this off? Because writes are slow within VDI. A hard drive can always read faster than it writes, and writes are just plain slow. So anytime we can eliminate large-scale writing, we can make the IOPS less overhead. We can make the disk faster. We can improve our experience. Next up, disable background defrag. This is a big one. There is almost no instance where I would ever expect this to be turned on. Now, a lot of folks will be saying, well, why? If I'm using non-persistent link clones, this would never matter because you're automatically going to be defragging your image before you upload it to the server anyway, number one. And number two, every time you recompose, any fragmentation you have is going to be gone. Now, what about persistent virtual desktops? Should you defrag those? The short answer is no. Why is the answer no? Because when we're dealing with fragmentation across your virtual file system, it's a virtual file system. It's not physical. So the whole idea of fragmentation as we know it on a physical hard drive does not exist anymore. It's within one large flat file, and you've got to remember we're not controlling the flat file anymore. That's up to the hypervisor. So any gains that you might be getting by defragging that image are going to be lost by actually performing the defrag. Why? Because defragmenting an image or a flat file within any kind of virtual environment will consume as much IOPS as it can. So if you have a 10,000 IOP storage device and you have 10 users using 10 IOPS, then everything's fine. But the problem is as soon as one of those 10 users flips on a defrag, you're immediately consuming all the IOPS that you can grab because the operating system is saying, well, I want to do this as quickly as possible. And within a virtual environment, the storage infrastructure is going to give it whatever it can. So what you've done is you effectively rendered any kind of storage implementation useless as soon as a single user turns on defrag. So get rid of defrag altogether. Get rid of the background, get rid of the foreground, pull it out of the image. You don't want it. The best thing you can do within your persistent images, defrag them before you start spinning them up. Start moving towards non-persistent link clones as soon as you can. But in the meantime, the gains are never, ever outweighed by the costs. The costs are just too high. Next up, set event viewer logs to 1 megabyte. Why would we do that? Because writing large, big, flat files, remember we said writing is slow, is going to slow the system down. So if we set those to 1 megabyte, they're going to recycle, the files are going to be kept small, and everything's going to be nice and happy. Next, set the event viewer logs to overwrite. We want those to cycle back out. We don't want to constantly append the file because appending is slow. We don't want to constantly rewrite. We want to just wipe out everything that's on the back end and go through it if we have to. If you can turn off viewer logs, do it. A lot of folks are not going to be able to do that because you have internal audits to worry about, you have security practices to worry about, and especially if when you're on non-persistent link clones, you need a way of tracking your users' habits when they do things they're not supposed to. Next up, disable hibernate. There is no legitimate reason as to why you should ever hibernate a VDI system. The other thing to remember is whenever you hibernate a system, it's going to write whatever's in RAM back to the hard drive and read it on boot. So writing 2 gigs, 3 gigs, 4 gigs worth of data and then shutting a system down is not doing anything for you. So instead, either have the system live or have the hypervisor automatically enable or disable your desktops, etc., etc. Disable Windows Search. This is a big one, and I'm a stickler on this one pretty much across the board. Now, in Windows XP, Windows Search isn't terrible. It's not a very efficient search engine, but it's not as bad as it is in Windows Vista and Windows 7. That being said, a lot of folks will ask me, why would I want to disable Windows Search if I'm trying to make search routines faster? Well, the short answer is when the operating system goes through and starts caching all the files on the disk for search, it does so in a very inefficient manner. It's constantly reading and caching, meaning that it's using a lot of IOPS. Usually you'll find the majority of IOPS traffic across an idle system is pretty much going towards Windows Search. So whatever idle systems you have, as soon as they're idle, Windows Search says, oh, I'll go and fill up my cache. I'll go and see if we can figure out what's on that hard drive. We want to get rid of that because the amount of machines that you have constantly caching that search routine is going to chew up so much IOPS that it will be faster to run a search without the Windows Search cache engine. Just to give you an idea, let's say, for example, we have 100 machines using 5 IOPS per machine just to cache that search data. That's 500 IOPS. Decent amount of traffic, almost 5 spinning disks. Now, if a user needs to run a search, instead of consuming that 500 IOPS constantly, there's an extra 500 IOPS just available to you. So anything you do with the disk, including searching, will be faster. Next up, disable machine account password changes. So any specific machine accounts that you have, you're going to want to turn those password changes off. Why? Because we're constantly going to be writing back to the registry, back to the file system, all the rest of those things. If your security department forbids this, I will be okay to let that one go. Next, force off-screen composition for Internet Explorer. This is a nice handy little trick. So the off-screen composition for Internet Explorer, what that means is instead of constantly refreshing on-screen, which is going to chew up video on a normal system, we're going to force it off-screen, meaning that we're going to let it compose and then push it out. Now, what does that mean in English? Because the CPU is rendering your video in terms of VDI, and because your network is encapsulating that video traffic on VDI, those two resources are going to be at a premium. So if we're constantly composing video on screen for little things, like when you scroll or when something changes or anything else like that, we don't need 30 frames a second with VDI. We need something that's going to respond quickly. So by forcing the off-screen composition, we're going to make the CPU load lower, the video load lower, the network load lower, and we're going to make things run faster. So even though it might affect the fluidity, the end result is the user's going to think, wow, this is really, really fast. Little things. Disable cursor blinking. Why? Because the GPU doesn't exist anymore. The CPU is rendering that cursor blinking every single time. Same thing, the network is encapsulating that traffic, and every single time there's a delta, that's what your communications protocol is transmitting across. If you get rid of that cursor blinking, you suddenly freed up a whole lot of CPU and a whole lot of network. All right, we got some more things to talk about. Next, increase service timeouts. Why would you want to do this? Because sometimes you're going to have resource contention within VDI, and sometimes services are going to time out. Now, when that happens, Windows is going to automatically attempt to restart the service, which is going to increase IOPS, CPU, and memory traffic. If we increase the timeout just a teeny bit, by as much as 20%, then if the system is low on resources, instead of constantly restarting it and using more resources, the service is just going to come back up eventually, and everything's going to be fine. Next, turn off unnecessary system sounds. You have no audio card inside your VDI server. It's not rendering audio via a hardware card. It's using the CPU to do that. So any system sound that you're doing is being rendered by the CPU. We want to get rid of that. Disable full window dragging. Now, we've all seen in some other versions of Windows, the older versions of Windows like 95, 98, whenever you drag a window, you just got the outline of it. Well, ever since 2K and XP came along, we said, well, hey, we should be able to see those window contexts while driving it. It's pretty. It looks good. The problem is that it increases video rendering routines by a great deal, meaning that the CPU and the network are going to be taking on that extra load. We don't need that. It's eye candy. Yes, it looks nice, but again, it's one of those things that's going to make a large difference in regards to optimizing your image. Disable, minimize, and maximize animation. Just like Windows dragging, we don't need to animate that window shrinking and growing. It's not a process that needs to be seen by the user. And in the end, a user cares more about having a machine that's responsive and gets their work done more than they looking at pretty colors. I mean, this might be different for some users, but this is what it is. Disable font smoothing. Why would we want to turn this off? Because more often than not, especially within VDI solutions, what we're doing is a carrot and stick approach. Some companies like giving users a nice brand new high-resolution monitor with their thin client just to alleviate the concerns that they're losing something. So with modern display resolutions above 1280 by 1024, something like 1360 or 1920 or anything like that, font smoothing does not play as big of a role as it used to. Within 1024, 768 desktops or 640, 480, yeah, that was a big deal. But font smoothing actually requires a lot of CPU and a lot of GPU rendering. We don't want that. So if we get rid of that, we increase the amount of bandwidth that's available to just about everything. Disable background fragmentation. That's a typo. I apologize for about that. We talked about that before. Disable Windows Update. This is a big one. You do not want any kind of single update, Windows Update process running on your image unless you're running persistent link clones. And if you are, handle this very carefully. Because what we've seen is that updates on systems, particularly security updates, system updates, operating system updates, are very intensive, especially when they come from Microsoft. So what you're going to find, and please do this kind of research on your own, when you run a Windows update on a system, physical or virtual, bring up Task Manager. Do a Control-Alt-Delete and fire off Task Manager. And I want you to evaluate two things. One, the disk traffic, which is going to be decent, but I also want you to take a look at the CPU traffic. Now, the compression scheme that Microsoft uses in its updates and their error detection units and all the rest of that stuff use a lot of CPU, way more than they should. But again, they're trying to be safe. We understand that that's necessary. So anytime that you run a Windows update, it's going to be tremendously intensive to your systems. A couple of things you might want to do. Stagger your Windows updates across your VDI if you have to run them in persistent desktop modes. That's number one. Number two, if you're using non-persistent link clones, you shouldn't be updating your images this way. You should be pulling them down, manually updating, pushing them back up, and that's called a recompose in most environments. And then every user has that specific service update. If you're doing it any other way, you are wasting resources. Now, if you have SMS or SCCM, same goes here. If you're using Alteris, again, same process. It really doesn't matter what update process you're using. The end result is always the same. Inventories, where it actually tries to discover what's on the machine, are very intensive. Updates are very intensive. Agents are very intensive. And it's idle resources we don't need. So if you're persistent, do what you can to minimize that as much as possible. Stagger it. Make inventories happen at most once a day. If you can make it every other day or every week, even better. Come to a compromise with your security department and see what kind of balance you can be made. An argument you might hear from security architects and security engineers is that I will never compromise security for the sake of speed. What you have to understand and what you can always relate to them is that this is not a standard desktop. This is not a standard laptop. This is a system that is present within my data center. It's within my firewalls. It subscribes to all my best practices in terms of server virtualization, because we're doing the same thing in VDI. This is a safer environment than what my desktops or laptops are exposed to. Therefore, I should be able to relax some of the aggressive security timings to take advantage of the fact that this is very expensive and we need to make it as cheap as possible. Remove unnecessary programs from the run key. Anytime you start a system and there's things running in the background, that's going to slow it down. It's going to pull everything you have. CPU, IOPS, memory, and network. Get rid of that. Remove unnecessary system agents. Good examples of that are if you have an aggressive firewall or an aggressive intrusion detection system, move it to an appliance. That kind of thing has no business being inside VDI. Your individual systems can be sniffed by external appliances. There's a lot of different ways to do that. If you have any relics left over from a P2V image, like audio agents or hardware agents or video agents, those are just chewing up resources. We want to get rid of those. Utilize, actually that's another typo. We want to say Service Pack 3. We want to be on the latest Service Pack for Windows XP. Unfortunately, it does not look like there's going to be a Service Pack 4 anytime soon. Service Pack 3 with all the latest optimizations is as good as you can do. Optimize any image integrated applications. We're going to be talking about that in a little while as to what we can specifically do for any applications that are stored within the image. We talked about some of these during the first part of our presentation. So just some general guidelines that you should follow. Number one, don't install the whole application if your users only use 60% of it. So if you have Microsoft Office in your base image and you only have one user using Visio, don't put Visio in the image. It's going to be extra bandwidth and extra startups and extra space that you just don't necessarily need to use. Number two, utilize the LSI accelerated storage driver. Now, in older versions of the hypervisors, they couldn't give this one away. I do believe in the newest version of both ESX and Citrix, you can get their newest drivers. In the event that you're running an old version of vSphere, an old version of ESX, an old version of VMware Tools, get the LSI accelerated storage driver. It will make a very large difference in how your disks perform. Check to see what driver that you have right now. If you don't have LSI accelerated, you're not running as fast as you could be. Disable memory dumps. In the event that a machine blue screens, a user does something they're not supposed to, an application fails, etc., the machine is going to go into blue screen mode and do a memory dump. Now remember, writes are expensive. Writes are very cost prohibitive, and we might not want to do those. So if you can, turn off those memory dumps, and if a machine does in fact have a blue screen, at the very least you're not going to try to dump the entire contents of a 4 gig memory module to your SAM, your NAS, your DFS. Disable offline files. Your VDI solution is never truly going to be offline. Everything is dependent on the network and everything working anyway. There is no point in having offline files at all. Perform a disk cleanup. Make sure this is done before you seal up your image and post it to your connection broker. Make sure things are cleaned up. Make sure your temp directories are clean. Make sure there's nothing just hanging around on the disk that needs to be done. Reduce the menu show delay. Now, there's a delay between clicking and showing in a menu. It's actually a registry setting. Reduce it as much as possible, and what's going to happen is it's going to accelerate your GPU, CPU, and everything else. And finally, this is a big one, disable screensavers. At the very most, I would expect a screen blank screensaver within your image. But the reality is this kind of thing should be handled by whatever accessing device you're using. So the accessing device should have a screensaver. The other thing to consider is modern hardware screens. So anything that's an LCD, can't get screen burn. So there's really no reason to have a screensaver unless you're talking about locking the screen for security purposes, for HIPAA regulations, for things of this nature. And again, blank screens are fine. Requiring a password upon re-entry is fine. And if you need to have some kind of pretty 3D screensaver, do it within your thin clients or whatever your accessing device is. All right, so that was a little long-winded. A lot of stuff to talk about. But next thing we're going to be talking about is Windows Vista specific practices. Some of these things are going to look very similar, and in terms of why we do them within Windows XP and why we do them in Vista, they're going to be very, very similar and very simple. There are some things that aren't, and we're going to talk about those individually. So Windows Vista, while not as popular as XP, is still a very powerful operating system and may be virtualized in some environments. Some people will laugh and say, you've virtualized Vista. I've seen people do it, and if you optimize it properly, it can be done well. Now, it's important to note that both XP and 7 are less resource-intensive as Vista. Unless your organization has a specific need for Vista, or you've done it already, it is recommended to use one of these other operating systems. That being said, there's a number of things that can be done to optimize Windows Vista. So we're going to go through these again. Install VMware tools. We talked about that already. Disable as many system processes as possible. Keep in mind, Vista, this makes a huge difference on, because with Vista, just about every system process is automatically loaded and automatically turned on. And this is because of the way that Microsoft built the OS. They expected we were going to have way more CPU and way more disk available to us by the time Vista came out, and that just didn't happen. So be very, very granular when turning these off. Turn off as many as you can. It's going to make a very large difference. Comms and LPTs, CD-ROM drives, turn them all off. They use interrupts. They use resources. Disable the superfetch service for the same reason. Vista's superfetch service is way more aggressive than XP's. Turning it off has huge benefits here. NTFS lacks as timestamp. Background defrag, event viewer logs to 1 meg. These are all the same as XP. Event viewer logs to overwrite. Disable Hibernate. Hibernate, again, huge difference in Vista over XP. Why? Because Vista uses more RAM. It uses a lot more RAM. It has a lot more services. Therefore, Hibernates are going to be even more painful in Vista. Disable System Restore for the same reason. You don't want System Restore in a Vista image. 7, same thing. XP, you can sometimes get away with it, although I'd still recommend it be turned off there as well. Now, System Restore is going to be constantly writing entire registry files, registry deltas, file system deltas, all kinds of things that waste resources, especially if you're in an non-persistently cloned environment. This is redundant. You don't need to do it. Windows search in Vista is a huge amount of resource consumption is spent on this. Way more than XP, way more than 7, way more than any other operating system you'll ever see. It is going to cache everything it can get its hands on. Every aspect of the file system, every read, every write. Turn it off. There is no reason to have it. The amount of IOPS it consumes is entirely overweighed by running a manual search and just having those IOPS available to you when you do this. Disable machine account password changes. Again, if your security group doesn't like this, that's okay. Force off-screen composition for Internet Explorer. This is actually more important for later versions of Internet Explorer that come bundled with Vista and 7, mostly because they do more in terms of eye candy. Therefore, if you turn off the composition, you're going to do a little bit better. Disable cursor blinking, same thing. Increase service timeouts, same thing. We want to make sure that if the service is running a little bit slow, Windows doesn't restart it and use up a lot more resources than it should. Turn off unnecessary system sounds in Vista. There's a bunch of them. Disable Windows full dragging. Same thing as XP. We're using the CPU to emulate GPU and network, so therefore we want to get rid of it. We want to disable minimize and maximize animation. Disable font smoothing, background defragmentation, and Windows Update. These all have the same repercussions that they have in XP, even though they use larger and more intensive processes. Remove unnecessary programs from the run key. Remove unnecessary system agents. Utilize Service Pack 1. Okay, put the latest Service Pack that you can on Vista, and I think that's a little bit old. Optimize any image integrated applications. We're going to talk about that in a moment. Utilize the LSI accelerated storage driver. Again, if you have any other driver in there besides the LSI accelerated, especially in ESX, get rid of it. Use the newer one. Disable memory dumps. Disable offline files. Same thing as in Windows XP, but again, just like in Vista, these have larger impacts. Perform a disk cleanup, reduce the menu show delay, and disable all your screensavers. Now, let's talk about Windows 7. This is going to look very, very familiar because 99% of everything you're going to be turning off inside Windows 7 is actually everything that you looked at in Windows Vista. Why is that? Because the two operating systems are very, very intrinsically linked. A lot of people consider 7 to be SP2 or SP3 of Vista, depending on what language you subscribe to. Now, that being said, the main thing you're going to find is that 7 is just optimized much differently than Vista was. So we're going to be talking about how those differences make an impact within your processes and what you can do to mitigate that. So Windows 7 is Microsoft's newest operating system. Being that many organizations chose not to implement Vista, the move to 7 will be a great jump for the enterprise. We're talking about literally an incremental leap here. Windows 7 will require a large amount of memory and disk resources compared to XP, so any optimizations you make will help the system run much better. Due to the fact that Vista shares many similar features with Windows 7, you'll find the optimizations are similar, but there are a couple of differences we're going to be talking about. Any version of VMware tools that you have in the image is going to be different for every operating system. So there are going to be little tiny minute differences. Make sure you're on the latest version, and again, that goes for 7 and XP and Vista equally. Next up, disable as many system processes as possible. Now this is one of the main points that makes 7 much different than XP, and different from Vista especially. when 7 came out, Microsoft said, well, listen, architecture hasn't responded the way we thought it was going to in terms of hardware development, in terms of CPU and memory and everything else. Instead of really fast single-core CPUs, we now have a whole bunch of slower multi-core CPUs. So the other thing that came out at the advent of Windows 7 is that netbooks started making a huge inroads to the environment. So 7, by and large, is much more efficient than XP, mainly due to the fact that it just does not load as much in boot. So the system processes within 7 are literally worlds away from Vista. Still, you have to scrutinize these just as much, but what you're going to find is if you work with Vista and then you immediately start working with 7, you're going to see a lot of deltas between the way processes are loaded and the way they're actually pulled from the system. But again, disable as many as you can. COMs, LPTs, and CD-ROM drives, yes, the drivers are better. Yes, interrupt handling in Windows 7 is better. It does not matter. They still use resources. We still need to turn them off. Superfetch. They actually made some improvements to Superfetch in 7. Turn it off anyway. It's still not going to help you. It has no good or decent effect within a VDI environment. It's more of a bane than anything else. Background defrag. We've already talked about how defrag is awful. You never want it within a VDI environment. This goes just as well for 7 as it does for anything else. Event logs to 1 meg. Event viewer logs to overwrite. Disabling hibernate, system restore. Again, these are all things that are all standard across all 3 OSs. Turn them off. Windows Search. Now, Windows Search in 7 is a little bit different than it is in Vista. It's a little more efficient. It's a little more high-reaching. It does a little bit more. That being said, the gains are still, they're just not there compared to the pains that you have to go through to implement it. It still uses too much IOPS. It still uses too much resources. And one of the biggest single gains you can ever do to improve the speed of a VDI system is turning it off. That in and of itself, if you do one thing and one thing only from this presentation and you implement it today, turning off Windows Search will instantly make your systems much, much faster. Disable machine account password changes, just like before, if security group allows it. Force the off-screen composition for Internet Explorer. Again, IE8, IE9, this makes a bigger difference than it would for 6 and 7. Disable cursor blinking for the same reasons we talked about before. And then the rest of this is going to seem kind of redundant, but we're going to go through it anyway. Turning off unnecessary system sounds. Again, same reason, CPU is rendering it. Disable full window dragging. Disable, minimize, and maximize animation. Very easy to do in 7. It has a huge factor in how the system performs. Disabling font smoothing, background defrag. Again, another typo that's supposed to be foreground defrag. No defragmentation in any of the operating systems at all. Just get rid of it. Don't have it. Disable Windows Update. Again, we talked about the reasons for that. If you have to have an update mechanism, make sure you have only one. Make sure it's tuned appropriately. Remove unnecessary programs from the run key. Remove unnecessary system agents. Disable your screensavers. Optimize any image integrated applications. Again, I know we've been saying we're going to talk about that. I promise we will. Utilize the LSI accelerated storage driver for 7 and make sure it's for the specific version of 7 that you have. Disable your memory dumps. Disable offline files. Perform a disk cleanup. Reduce the menu shut delay and increase the service timeouts. So, with that, we're finally going to talk about applications. Now, generally, most applications now have the ability to be run within a virtual environment. Now, applications should always follow the following best practices in order to be run to their full potential within a VDI environment. Whenever possible, virtualize and stream the application to your VDI users. Use SynApp, use AppV, use SVS, use whatever you have to decouple that application from the operating system. Why? Because then you can get down to one clean image that really doesn't have a whole lot on it. It might have, if you're using an internal virus protection engine, it will have that, and it might have a copy of Microsoft Office if you decide to integrate it. But other than that, you're not going to have a whole lot within that image, and that's the way it should be. Segregate application virtualization storage pools from VDI storage pools unless QoS or quality of service of each can be measured and accounted for. Now, why am I such a stickler about this? Because if I know through my monitoring tool or my assessment tool that my users consume X amount of IOPS, and I know that my storage frame can deliver Y amount of IOPS, as long as X is less than Y, I'm in the clear. The problem is that if I start putting multiple things, multiple issues, multiple systems within one storage pool, and I can't guarantee my IOPS, I have failed my users for VDI. Because odds are, if we're doing streamed applications, as a company, the most efficient way to do it is to do it for everybody, not just for my VDI users. Meaning that my applications that I'm streaming, my applications that I'm virtualizing, if they're on the same LUN, aren't just going to be for my VDI users. And unless I can guarantee that that quality of service, the IOPS for everybody in the whole company can be guaranteed, then all the work that I've done for monitoring and assessment goes out the window. So segregate it. Smaller, cheaper storage devices that can guarantee QoS are much easier to manage than it comes to large refrigerator-class enterprise environments unless you can do QoS. Now, a lot of the new big box storage devices from all the big vendors, and I'm not going to mention their names because you already know who they are, can guarantee QoS in certain areas. Use it. Make sure that your storage group is educated on how to do that, because that's the only way you're going to be able to get away with a consolidated storage environment with and without VDI. Enable local caching of application data whenever possible. A lot of applications have this support nowadays. There are some exceptions. Some applications, and we might get a chance to talk about those later, do bitmap caching. Now, bitmap caching in certain applications can slow things down. You might be saying, well, why? Because the amount of writes that it's making back to the disk can actually slow the operating system down. So again, be very careful. Only install the features of the application that your user base requires. Do not over-install a product. And we've talked about this before with Microsoft Office that goes for everything else that you have. If your user base requires 80% of a product, install that portion of the product. Don't over-install it. Now, in the event that over 80% of your user base requires a piece of software and your licensing allows it, integrate the application within your master image. Now, why would I do that when I just said that you should be streaming all your applications? Well, the simple fact of the matter is that bandwidth is at a premium for your networking and everything else that we have here. So if we can relegate it to the image, and especially if we're using non-persistent link clones, it's not a bad thing to do this. And because of the fact that during our assessment and our monitoring, we already know what kind of IOPS the application is using, that's okay. Now, does it make it a little bit more difficult to guarantee QoS just for a specific application? No, as long as your images are running properly. But if you have a really, really big application and you want to maintain QoS, even if over 80% of your user base uses it, you might want to take a look at segregating it just so you can guarantee that if there's a problem, you can easily and quickly figure out where it is. This, again, lends itself back to monitoring tools. You need something that's going to give you insight into not just user behavior and what the users are doing on their system, but you also need insight into your hypervisors, be it your Citrix or your Hyper-V or your ESX hosts. You need insight into the virtual network switch present within each of those hypervisors, and you need insight into your SAN environment. So if you don't have a monitoring tool that can do all four of those things, and consolidated would be nice, look for a new one. Ask the application vendor if they have a separate version of their product specifically designed for VDI environments. Now, you wouldn't think you'd find a lot of this out there, but I'm going to tell you right now, it's getting more popular. A lot of vendors are starting to develop products that have slightly lower overhead just for such occasions. Now, 3-4 years ago, you'd hear a lot of, yeah, we don't support VDI. Nowadays, if you're hearing that, you're going to have a serious problem with an application vendor. It might be time to start looking for a new one because there are no legitimate new vendors that should not be supporting VDI. Finally, this is the most important one. Ask your application vendor for specific instructions on application tuning within VDI environment. Now, they wrote the app. They know the app better than anybody could possibly do, and in all likelihood, they control the source code as well. Now, if they have all of these things, they can tell you how to optimize. Now, if your local engineer says, I don't know, go above them. Tell them that you're very serious. Tell them that you might be up for license renewal, and you want to make sure that this application runs as quickly as possible. By doing that, you're literally leveraging the engineers who wrote the product and making it run as quickly as possible. This is the best advice that I can give you in regards to application tuning. Antivirus. Now, this is a little bit tricky. Nearly every enterprise-level company in existence today uses a form of AV software within their environment. I'd be very hard-pressed to find one that doesn't. Security is paramount. Intellectual property is paramount. Our systems are important, as is the lifeblood of our organization, which is IP, intellectual property. It's important to note that VDI systems must be managed in a different method than their desktop or laptop counterparts. Now, again, this is going to get some ruses from your security department in the classic adage of, I will not give up, security for speed. But again, what you have to convey is that VDI systems are cemented within your data center. The exposure they face versus laptop users is drastically different. This has to be contended with. Now, this is going to mean a lot of things. This is going to mean changing your update intervals. changing your DAT enforcement or your update enforcement intervals, changing how often local scans take place. I mean, ideally, within any kind of VDI environment, you shouldn't be doing local scans. Now, I realize it's not always possible. Minimize them, randomize them, stagger them, make them as long apart as you can. Just like defragmentation, virus scanning is an incredibly intensive IOP process. This can kill a VDI farm. Be as careful as you can with VDI tuning when it comes to AV. And again, just like with application tuning, the best idea is to talk to your vendor. They've done this before. Every AV vendor out there has done some sort of tuning for VDI. They might not advertise it, they might not talk about it, but they know how to do it. Contact them. Find the engineering resources that can help you out with this. Now, because resources are limited and AV software is highly disk intensive, it's important to follow the following guidelines. If your vendor provides such a product, implement an appliance-based host-centric AV product for your VDI pool. Now, within the last 6 months, there's been a number of these released. Essentially what this means is instead of every single client doing a virus scan, having an agent running and multiplying that times however many clients you have, you put the AV agent at the hypervisor level. First of all, it's way more efficient. Second of all, this is more secure. Way more secure because you're looking at things at the hypervisor level where the hypervisor is exposed to everything. God forbid a virus comes out that impacts VDI. Wouldn't you like the ability to actually know whether or not you are infected and how to kill it? Very, very important thing to look at. In the event that your vendor does not have one, you might want to talk to your security folks and say, maybe we should look at somebody who does. This is the kind of thing that's going to make things more secure and faster. It's a win-win for everybody. Limit AV system update checks to at least 2 hours and make sure that the updates can be randomized across this time. The longer this period, the more performance gains can be realized. There is always a bit of give and take between the desktop teams, the server teams, network and storage teams, and security. Basically, put this in the best balance that you can. The more time that you can get, the better things are going to perform. The security group is going to want this number lower. You are going to want it higher. Limit AV system enforcement checks to at least 2 hours. And make sure that they are also randomized. The longer this period, the more performance gains can be realized. Just like system update checks, same thing. Make sure that they're pushed out. Now, the funny thing is that enforcement checks you're going to be able to get away with a little bit less than you would with system update checks, because DATs or virus updates are paramount towards killing viruses as they become introduced. System updates are less frequent, so see if you can push back a little bit more on that number and see if you can get a little bit more out of it. Disable script scanning. This is a big one. This one takes a lot of people a while to learn. Script scanning is one of the banes of EDI. Scripts in and of themselves are not very efficient because each portion, each line of a script has to be compiled into memory and executed, and the next line gets read. It's a very, very slow process. Native compilation of programs is much faster. Now, the problem is if you have script scanning, you're adding a whole other level to the whole process. So what you're doing is you're not only compiling each and every line in memory, you're also scanning every single line. And because every single line needs to be scanned because one single line doesn't constitute a virus, they pretty much wind up caching the whole thing and checking every single line as it becomes read in memory. That is horrible. It's a terribly memory and CPU intensive process and can severely limit a VDI environment's resources. Next, make sure your products are as up to date as possible. If your virus engine is more than 6 months old or a year old, look for an upgrade. A lot of vendors are introducing a lot of optimizations in regards to VDI into their later engines. See if your vendor is doing that, see if they can help you. Consult with your specific AV vendor to enlist their help in tuning their product for a VDI environment. And again, just like with applications, this makes a huge, huge difference in the way things are run. So that's pretty much it. Ladies and gentlemen, thank you so much for your time. And with that, I'd like to turn everything back to Terakai.
Thank you, Matt. Let's jump right into the Q&A here. We've got a few questions queued up, and we'll try to keep them brief. I know we're running a little late today, but thank you for bearing with us. The first question I have is from Jenna, and Jenna says that we're planning on using Windows 7 with our new VDI deployment. Won't the out-of-box image settings be good enough for a proof of concept?
That's an outstanding question. The short answer is no. And we've talked about the reasons as to why Windows 7 needs to be optimized. And granted, 7 is much, much more efficient than Vista was. And again, this is plainly evident when the fact that you can run it on a 1.6 gigahertz little netbook, and it runs just as fine as it did with an XP. That being said, the things that are really going to kill you are the caching service for Windows search. A lot of the system processes are not as efficient as they should be, and Windows updates. Those 3 alone, not counting the 30 other things that we talked about, are going to have a huge impact within your infrastructure because you're multiplying those resources out by however many clients you have. Those are the bane of idle resource consumption. Between that and virus scanning, you've got a perfect storm for a system that's just going to choke the lifeblood out of whatever hypervisor that you're running. So I appreciate the fact that it's very easy to spin up a Windows 7 machine. You just put a disk in the drive and P2V it, and all that's good. And yes, it is fast, but it's not good enough. Resource consumption is the main limiting factor towards inhibiting VDI success. We need to make sure that that never happens.
Excellent. Our next question here is actually from Brett. And Brett says, we are currently running Adobe Reader X in our environment. Are there ways to tune that software in particular?
Yes, that's an excellent question. Now, typically we don't get into application-specific best practices, but again, Adobe is one of those things that's pretty much ubiquitous across the entire frame. I mean, one way or another, if you're in a major enterprise organization, you're using Adobe. So that being said, one of the things that I spoke about during my presentation relates very heavily to Adobe, and that is bitmap caching. Now, Adobe does lots and lots of bitmap caching because essentially what it does is that when it reads a PDF, it interprets it as a bitmap and then saves it to the local disk. The idea being is that if it's cached, it can be displayed to the screen faster instead of decompressing that PDF. The problem is that bitmap caching within Adobe is very aggressive. It uses a lot of IOPS, it uses a lot of memory, it uses a lot of CPU. So number one, turn it off, because it does not matter which version of Adobe Reader you're running, 8, 9, or 10. They all pretty much behave the same way. The second best piece of advice that I can give you in regards to Adobe is talk to Adobe, because there's a lot of different optimizations that you can make across the different versions. Even different service levels and service packs of Adobe have a host of different settings that affect that version and only that version. So bitmap caching is one small example of how you can tune Adobe, but there's another huge subset of resources that can be pulled for that one application. And I know this seems daunting, because if we're just talking about this much work for Adobe, what are we talking about for something like Microsoft Office or AutoCAD or anything else like that? And again, VDI is not something that should be jumped in lightly. It's not something you want to work in head first. This is why vendors like Terakai exist, because they have the ability, they have the resources, and most importantly, they have the experience with working with hundreds and hundreds of clients who've done this before. So utilize them and utilize your software vendors wherever you can, because ensuring success means going through every single process like this with a fine-tooth comb.
Matt, here's a question from Sudhir, and I'm wondering if this might be one where we reference back to part 1 of the webinar around proof of concept. But the question is, if I have a server in my data center that is serving up VDI images,
Yep.
Can my users working remotely connect to these VDI images over the web? What kind of client resources do they need to connect to that VDI image?
Whole lot of not much is basically the short answer of it. And yes, this was covered in part 1. I strongly recommend anybody who hasn't gone through it to go through it already. Now, the short answer is it depends. Yeah, I know that's always a lot of fun because the it depends answers are usually the most complicated. It depends on your connection broker. Because what's going to happen is the amount of resources on both the client and the server end are dependent on what the client is doing and what the broker is compressing and what information is going back and forth. And I realize that's really big and really vague, so let me go into more detail. Let's talk about a couple of brokers in specifics. Now, let's say you're using a simple bottom-of-the-barrel broker. You're not using any broker at all. You're just using remote desktop connection, or also RDC using the RDP protocol, remote desktop protocol. Now, that is the lightest protocol you could possibly use without going to an ultralight Linux protocol. Logic being, the only thing that it's really doing is transmitting any kind of screen updates or deltas, as we discussed before, as well as keyboard and mouse movements back and forth. Now, individual protocols, individual connection brokers, they each have their pros and cons. Some flourish well in some environments, and some will die in others. RDP is pretty much the lowest entry point of a VDI protocol. Its utilization is remarkably low. In terms of raw numbers, it's going to vary. Specifically, it varies with the amount of resolution that you have and what else you're pushing across it. Now, off the top of my head, the raw numbers for RDP with a 640, 480, 256 color screen, which no one uses anymore, is around 25 kilobytes per second. Now, typically, for every step up in color or screen depth you're using, you can add around 3 kilobytes per second. So if you're doing something like 1280 by 1024 res, that's going to be a great deal bigger. If you're doing dual resolutions of 1920 by 1024, obviously that's going to be a little bit more, because that's just the way RDP varies. Now, if we're talking about a couple of different protocols, they're going to behave differently as well. If we're talking about PC over IP is a very heavy protocol in terms of what it uses on both the local client for VDI, what it uses on the endpoint, and what it uses for network resources. Instead of talking about kilobytes per second, we're going to be literally talking about megabytes per second. That number is going to vary depending on what the client is doing with multimedia resources more than anything else. So if you're doing any kind of streaming video, streaming audio, anything like that, the amount of resources you're going to use with PC over IP is huge. Now, that being said, if you're doing rich media over PC over IP, you can't go below 50 milliseconds of latency, because it's just going to not work for anything. Now, if you're not doing rich media, if you're just doing basic, I'm doing Microsoft Office, Excel, and things of this nature, you can go much higher than that as long as you have the bandwidth to accommodate that. For specific numbers, I strongly recommend that you take a look at VMware's website. They actually have numbers on different display resolutions, different worker types, and they have it in a nice little XY grid that's going to help you out a lot. Now, in terms of why does it consume so much on the computer side for VDI and on the client side, it's because of the compression algorithms it's using. It's doing a lot of really cool work in how it's not really efficient to scrape the whole screen and compress that over the wire and put it up on your other screen, because specifically streaming video and audio consume a lot of resources. So they use something called a recompression agent, where it will take the compression stream that it's going to be sending to your screen, decouple it from the VDI session, recompress it as a separate stream, and then present it on your thin client or your endpoint device. So this is really cool. The problem is that compression is, well, it's resource intensive. It's going to use a lot of CPU, and it's going to use a lot of memory. So unfortunately, when it comes to PC over IP, the variables are huge. So it depends on your specific environment. Now, if you're using something like ICA, ICA is pretty much the Swiss Army knife of protocols. It can be worked in a very high latency environment. If you're doing non-multimedia stuff, it's not going to be using too much in terms of anything at all. It's very similar to RDP in terms of what it uses in terms of consumption. It behaves well in high latency environments as well as low. But again, if you're using any kind of multimedia direction, any kind of MMR, the amount of consumption on the CPU side of the VDI, the memory side of the VDI, as well as your thin client is going to be high. So again, I apologize for the long-winded response, but the short answer is it depends on what you're doing.
Excellent, Matt. Thank you. We've got one last question, and then we're gonna wrap up. We can certainly follow up with others offline if need be. We've had a series of questions that have come in regarding antivirus, specifically as it relates to government-mandated HBSS and McAfee. Can you speak or talk to any of these government mandates and how that would come into play with VDI?
Essentially, we all have one boss one way or another. And in terms of government mandates for security, your ace in the hole is going to be appliance-based VDI, because a lot of these government mandates stipulate very, very specific times for service updates, for outage updates, and even in certain levels for how a system is supposed to be behaving if and when it is actually broken into, something like an intrusion detection system. Now, with these more stringent guidelines, there's only so much you can do to relax your timings within a VDI environment if you want to fall inside the realm of the law. That being said, the only way that you can make anything better is to go to an appliance-based VDI solution. And by doing that, even though you still have the same highly stringent guidelines in regards to the government requirements, etc., the difference is instead of pushing all these things out times however many users, you're only doing it at the hypervisor level, and you're only doing it once. And on top of that, because of the fact that you're watching the traffic that's going back and forth to the hypervisor, that means you're not just limited to the local machine. You're also taking a look at the vSwitch, the hypervisor CPU, the hypervisor memory, the hypervisor network going into and out of the hypervisor. And what happens is not only do you wind up with a faster methodology that can implement the current stringent requirements that you're speaking of, but you can also get something that's going to be more secure than anything else that you can put into a VDI environment.
Excellent, Matt. Thank you. And I'd like to thank all of you again for your participation and insightful questions. I hope this webinar met your expectations. If desktop virtualization is in your IT roadmap, please join us for the third and last part of this series on September 14th. The dates and topics are on your screens now. If you missed part one in this series, as Matt has indicated, please visit the Terakai website and watch a streamed archived version. Today's webinar will be archived in the next few days. Terakai will be hosting these regularly, and we'd love your input on topic ideas. Thank you again, and good afternoon.